All right, so the first thing we're going to learn about today is mutually exclusive events. This is AKA impossible events. Okay? These are impossible events, so this means that this is two or more events cannot happen. Oh boy. At the same time. Thank you. A complement is an event where the set of all outcomes are not included. So we'll get a little bit more into that. Again, I'm just kind of giving you some meat and potatoes before we get into the actual math of it, okay? There's just a lot we need to know. So mutually exclusive means impossible events or two or more events cannot happen at the same time. Complement is an event where the set of all outcomes are not included from the original set. Okay? We have our addition rule, which would be the probability of A union B equals the probability of A, these are just events, plus the probability of B minus the probability of A intersect B. We'll talk about what those U's and like upside down N's are in a minute. Now, if we have a mutually exclusive event, we have the probability of A intersect B would equal 0. Again, this is just for mutually exclusive events. We have this upside, like this N type of shape, or upside down U. That means the word and that is known as the intersection. I kind of ran out of space, guys, so my apologies. I'm going to write a little bit more over here. We also have this U. This is just in continuous over here, which means the word or, and this is known as a union. Okay, so for Venn diagrams for mutually exclusive events, we're going to state that the Venn diagram of mutually exclusive events have an empty, Wow, sorry, this is really dragging today. Intersection. So, just for visualization purposes, if we look here, we're going to talk about a mutually exclusive event. That's telling me that if I have event A and if I have event B, these do not intersect. There's nothing in common between the two events. Okay? Like if you were talking about pets that people have, right? And event A is that people have a cat. And event B is they have people have a fish. Are cats ever fish? No, so you can't have there's nothing in common there. Does that make sense? Now, non-mutually exclusive means that you're going to have event A, you're going to have event B, and something's going to overlap right here. That overlap is the probability of A intersect B. And that means here it's equal to 0. Here it's not equal to 0. Now, for something like this, if you think about it, again, let's talk about our pet example. Probability of A, let's still keep that as probability of them having a cat. Probability of B is some of people having a pet that has 4 legs. Does a cat have 4 legs? There's your intersection. Does that kind of make sense? Okay. All right, now this next part, my apologies, it might get a little cramped, but just kind of stick with me. I'm going to try to use a nice light color so it shows up on the black, but anything outside the circles within the Venn diagram are the complements. And those mean the word not. So when we talk about the complement of A, we're talking anything that is not A. If we're talking about the complement of A intersect B, we're talking about everything that is not this small part. Okay? So that usually happens outside the circle, and we usually label that with a C. Now, if I remember correctly, the Ed puzzle should have gone over how like all of these probabilities should be like 100%, right? They all have to add up to 100, right? Okay, so we're gonna need that information coming up. All right, so anybody still writing this down before I move on? I know it's a lot of info, but it's all good info, I promise. All right, so example 1, we're just going to identify whether or not we have mutually exclusive events here. So Robert has a deck of 52 cards. He randomly selects one card and considers the following events. Event A, picking a card that is a heart. Event B, picking a card that is black. Event C, picking a card that is not a spade. So we're going to identify if the following are mutually exclusive and draw the corresponding Venn diagram. So we're looking at the probability of event A and B. So A is picking a heart, B is picking a card that is black. If you're picking a heart, is a heart, do we have black hearts in that? No, we don't. So in this case, are they mutually exclusive? Yes. Can't have a black heart. According to Disney, you can have a frozen one, just not a black one. So if we were to draw the Venn diagram for this, here's event A, here's event B. They do not intersect. Questions so far? So if you can physically say, no, this can't happen, then it is mutually exclusive. Okay? If you can say, yes, it can happen, then it is not mutually exclusive. So let's take a look at this next one. It says event A and event C. Event A is picking a card that is a heart. Event C is picking a card that is not a spade. If we pick a heart, did we not pick a spade? Yes. So this is no. These are not mutually exclusive, and it's because a heart is not a spade. And if I drew the Venn diagram for this, here's event A, here's event B, we will have that intersection. All right, for next one, event B and event C. So event B is picking a card that is black and picking a card that is not a spade. The question here is, if we pick a card that is black, could it be something other than a spade? Yes, it can be. What can it be? A club, right? So this is not mutually exclusive because we have clubs that are black, right? And we would have the same Venn diagram. Questions on that? Okay, let's take a look at example 2. So one thing that's nice about this one says two mutually exclusive events A and B have probabilities A 1/10, B probability B 1/5, and find the probability of A union B and the probability of A union B complement. That means not. Okay. So in this case, if they are mutually exclusive, we know that the probability of A intersect B is equal to 0. They don't mesh, right? There's nothing in common between the two. So if I use my formula, probability of A union B equals the probability of A plus the probability of B minus the probability of A intersect B, I can just substitute this in. So the probability of A union B is going to be probability of A, which is 1/10, plus the probability of B, which is 1/5, minus A intersect B, which is 0. So it's not technically there, right? So what's 1/10 plus 1/5? Good. 3/10. Now the next part, they're saying find the probability of A union B complement. Okay, so this is coming back to what we learned yesterday during that ed puzzle. Everything equals 100%. Okay, but we're using fractions, so in this case, everything has to equal 1. So in order to find the complement, we're trying to find everything that is not the probability of A union B. So that is 1 minus 3 over 10. What's 1 minus 3 over 10? Good. 7 tenths. So there's that one. And there's that one. Are there any questions so far that I can address? Yes.
Is 7 tenths the answer, or is the whole equation?
Well, they asked you to find both. They asked you to find the probability of A union B, so that's in pink. So we found that 3 tenths, right? And then they said find the probability of A union B complement. That's taking 1 minus that probability of A union B. I'm sorry?
It's just 7 tenths.
Yes. Yes. Because remember, mutually exclusive events mean that intersection is 0, right? Because those two circles for the Venn diagram don't move. They don't come together. There's nothing in common between these two events. So if I go back up here, you see how like these two are here? This is what determines if there's a number or not. But that those two events merging together doesn't happen. So that's why it's equal to 0. So mutually exclusive events, like I made sure we put this right here too. Mutually exclusive events, the probability of that intersection is always 0. So you don't need to worry about it. You can put in 0 if it helps with clarification. But either way. Yes. Yes, that's exactly it. Nice job. Any other questions? Yeah, you would put this in if you have non-mutually exclusive events. Yep. Anything else before? I am going to probably erase just a little bit here because it kind of went into example 3. I'm trying not to erase too much in case you guys think of a question a little later on. Okay. Anything else before I move on to example 3? All right. Example 3, A and B are two mutually exclusive events. The probability of event B occurring is 5 times that of event A occurring. Given that the probability that one of the two events occurs is 0.18, find the probability of event A occurring. Now, here's a couple of things. So first off, what do we know? Okay, and what we know is, first off, we have two mutually exclusive events, which means the probability of A intersect B is equal to what? 0, right? The other thing we said is that the probability that one of these two events occurs, that means that's your OR. So the probability of A union B is going to be 0.18. And then lastly, they're telling us that the probability of B is 5 times that of event A. So that means this is going to be 5 times the probability of A. So now what we're going to have is, if we take a look, we are going to substitute all this information into the probability of A union B, just using our addition rule, equals probability of A plus the probability of B minus the probability of A intersect B. So this we know. So that's 0.18. This we don't know. So I'm going to leave that alone. The probability of B, I'm substituting in this right here. So that's plus 5 probability of B. And this we know is 0 since it's mutually exclusive. So want, that's gone. So what do I do? Where do I go from here in order to solve for the probability of A? Who's got an idea? Emma? I'm sorry? Close. I wouldn't divide the 5 just yet. Shane?
Combine probability of A plus 5 B.
Yeah, so oh, I see why you did that. Sorry. I made a boo-boo. That's supposed to be A. I don't know why I put B there. That's A. Sorry. There we go. That's better. So we're going to combine these because they're both the probability of A. Sorry, Emma. I understand why you went the direction you did now. Sorry about that. So this is actually going to be 0.18 equals 6 times the probability of A. And we're going to divide both sides by 6. So I'm going to get that the probability of A is equal to 0.03. Or what's the percentage for that? 3%. Very good. Did that on purpose. I want to make sure you guys understand the difference between 3 and 30. Questions on that? Yeah.
What is the probability of one of them happening 0.1, but B is 5 times A? That's 0.1.
Okay, so you got to remember when you're doing an OR event, it could be this or this happening. It's not, how can I state it? It's not just the probability of one happening. Because when you're talking about the probability of a union, you're saying this is the probability that this or this can happen at any time. The and is more specific, where it's like, okay, that intersection, it's only going to be a small sliver of both. Does that kind of make sense? Any other questions? Okay. All right, example 4, the PNHS choir has a tenor, 3 soprano singers, and a baritone singer. A baritone singer and a mezzo-soprano singer. If one of their names was randomly chosen, determine the probability that it was the name of the tenor or the soprano singer. So the first thing we need to ask ourselves is, are the tenor and the soprano a mutually exclusive event? Yes or no? Who says, yep, gotta be? Who says, nope, they can combine somehow? How many of you have ever sang before in a choir? Maybe we need a little background knowledge. So here's the deal. You could be an alto, you could be a soprano, you can be a baritone, you can be all these things. Because it's all about the octave of your voice. If you are a soprano, you are not going to be an alto. If you're an alto, you're not going to be a soprano. You can't like mix these two together. So if I can't mix these two together, is it a mutually exclusive event? It is a mutually exclusive event. It is. Because there's no way on this earth that a tenor singer can be a soprano singer at the same time. Does that make sense? Okay. So this is definitely mutually exclusive, which means the probability of A intersect B is equal to 0. So what we're going to do here is we're going to find the probability of finding the tenor. Actually, let's make this T intersect S. That'll be a little better, right? So the probability of having a tenor is we have one whole tenor out of these 6. So that's the probability of you having a tenor. All right. So this is the probability of the tenor over the total in the choir. Ooh, can't spell. Okay. And now we're going to do the same thing for the soprano singer. That's going to be, we have, looks like 3 total soprano singers out of the 6, which is going to be 1/2. And remember, this is the total of soprano singers over the total in the choir. So now we're going to take this information now and apply it to our addition rule. So probability of tenor union soprano equals the probability of the tenor plus the probability of the soprano minus the probability of tenor intersect soprano. So this leaves us with 1/6 plus 1/2. That's 0, so we don't need to worry about that. That should give us 4/6, which is 2/3 reduced. Questions? All right, let's move on to example 5. So we've done a lot with mutually exclusive events. Now I want to show you one that is not mutually exclusive. Okay? So you roll a 10-sided number polyhedron that has the numbers 1 through 10 on its faces. Each face has a different number. You observe the number that ends up on top. Let A be the event the number is less than 8. Let B be the event the number is even. All right, so the first thing I'm going to do is the probability of A. Okay, I'm just going to kind of make like a little list like of this event. So if we're talking less than 8, so that's 1, 2, 3, 4, 5, 6, and 7. Probability of B is that it's an even number. So that'll be 2, 4, 6, 8, and 10. So that takes care of find probability of A and find probability of B. Now they want us to find the probability of A intersect B. Now the question you need to ask yourself is this. Are these events mutually exclusive? If they are, it's equal 0. If they're not, it's equal what? So the question here is, between these two events, is there anything common? What matches? 2, 4, 6. So here it's 2, 4, and 6 match. Because I find that here, I find that here, and I find that here. So if I want the probability of each of these, the probability of A is going to be 7/10. The probability of B is going to be, looks like 5/10, which is 1/2. And the probability of A intersect B is going to be 3/10. So we have something there this time. Okay? So this is non-mutually exclusive. All right. So this part takes care of letter A. Now letter B, all we're doing is we're setting up the addition property. So this is going to be probability of A is, let's see, 7 over 10 plus the probability of B is 1 over 2 minus 3 over 10. Part C is solving that. So the probability of A union B is going to be what? Who can tell me? Anybody? Good. 9 over 10. That's it. Questions? I want you guys to try 6 and 7 on your own. One is mutually exclusive, one is not mutually exclusive. I want you to identify the difference. I will post the key so you guys have it though. Okay? But try it on your own first and then let me know if you got questions. After that, you can complete your delta math. Okay? Anything I can address before you guys get going? Okay. Those who are watching at home, have a great day.